Hi guys, welcome back. Today we are going to learn about advertisement, and previously we have seen lots of different things in the programming, and in the programming session we just made a basic application, and now we are going to take a look at the advertisements and how the device advertises, basically from the peripherals perspective. So in Bluetooth communication, we have two types of devices. As you know that we have a slave device and a master device, and the slave device is the peripheral, and the programming that we are doing here is all relevant to the peripherals perspective. So first we are going to learn everything about the peripherals, and then in the end, after we finish everything about the peripherals, because mainly we use our devices as peripheral, so it's important to study all the basics. So today we are going to learn about the advertisements. Advertisements are basically the data packets that are sent by the peripheral device on air using some special channels that are allocated to the BLE, and we will see that. So this will be an overview. We will study advertisements in details later on. We will move to the next session, which would be services and characteristics. Basically the data transmission is not so simple in BLE because of the standards. There are lots of standards that we have to follow to transmit data from one device to another, so we have to take care of that. Now we will start with the advertisements, and I will try to give the details about the most of the aspects of advertisement and what are the specifications of advertisement and everything. Let's first start from the basics. So how a device or a slave device shows its presence, like a slave device is there, how do the other devices know about this? So a master device basically is scanning for the advertisements, and as we know that the advertisements are present on specific channels. For example, this one is the channel 1, channel 2, and channel 3. They are apart in terms of frequency, so that there is no interference among them. So now let's see, the slave device will transmit some advertisement packets on specific channels. So these channels are the 1, 2, and 3, these channels, and all the other channels that you are seeing in blue color are basically the data channels, and they are the secondary channels. The channels are set further apart to reduce the interference. So what if I'm advertising, another BLE device is also advertising on the same channel? How does it work? You might have this question in your mind, so I wrote down these questions so as to answer them as we move on with our tutorial. So the devices which are advertising, they take a very small amount of time, and which is represented in terms of milliseconds, and we have these special time values. We are setting these advertisement values later on. We will see how we set them. We have already seen them. Basically we are just setting these values so that our advertisement is just for a couple of milliseconds, and then the advertisement will not be on the same channel anymore. So for all of the other time, the channel is open, and it's easy for the other devices to start advertising, even though if we have so many devices there. But if the advertisement is just for a couple of milliseconds, then it's not a big deal for other devices to keep on advertising during the same time, because we have 3 different channels for that. Okay, the next question that comes into our mind is how master device knows the advertisement is from the same device. So for example, if the slave device is sending some data packets on the channel 1, how does the master knows that is the same device is sending some data packets on this channel and on this channel? Basically, every device has an address, and that address represents the slave, and the master device will read this address, and it will know that it's from the same device that is sending the data. Data packets are basically the advertisement data. Let's move to the next question. How devices know that they are connected with each other? In a Bluetooth, when a slave device advertises some data, after the advertisement, if the master device is interested and it wants to connect with the slave device, it's going to send a connection request, and then the slave device is going to receive this connection request, and then the slave device is just going to start a connection. If it allows the master device, then the connection is established. Once the connection is established, then they can communicate over these channels, data channels, and there is a special connection interval that is set so that after some time the master device is going to send that connection interval. If the slave device responds to that connection interval request, it means that the connection is still established between the devices. So basically there is a special time limit, and we can set this time limit to a couple of seconds or maybe many seconds, but normally it's just 3 or 4 seconds, so that our disconnection time is good. For example, if our device disconnects, then within 3 or 4 seconds the master device knows, because after 3 or 4 seconds it's going to transmit a connection interval request, and then it's going to read it, and then finally it will see if the device is connected or not. The next question is, why do we advertise so many things in advertisement? So for example, we have so many things like the transmission power, the name of the device. Sometimes we include the services UUID, which is universally unique ID identifier, and we also include some other stuff. We will see that in a short time. So why do we include so many things? Basically, Bluetooth is a standard communication, and it has lots of things in it, so you can make any type of application that you like. So basically it has standardized a lot of things in it, so we can add as many things as we want. For example, our device can advertise some manufacturer specific data as well, so that you can advertise it if you have some special way of communicating with the other device. So you want to make it secure, you want to receive some special data on advertisement that you want to see, and then you want to connect or some other stuff, whatever your purpose is. Basically it allows you to do all of this type of stuff, so it's really good in terms of its flexibility. We can advertise so many things because of the standardization, but it's not necessary to advertise everything because we have a limited packet for advertisement. So we will just advertise whatever we like to. It all depends on our application's requirement. So the last question is, why do we need to properly format our data? The reason for this is that the SIG, which is the special interest group, they wanted a standardized communication between many different manufacturers' devices. So the Bluetooth is basically a portable communication, so they wanted it to be platform independent, and it can be supported by multiple devices. So they standardized the advertisement and everything, so that any device which can support BLE can easily see all these advertisement packet data, and can easily recognize what is the data saying in the packets. Okay, now we are going to see the modes of advertisement, and we have many modes of advertisements. There are other ways like extended advertisements and periodic advertisement. We will not discuss that, but we will just see the basics. There are 4 modes of advertisement. The first one is general advertisement, directional advertisement. Then we have connectable and a non-connectable. We are studying from the slave's perspective, so These are the basic modes of advertisement. So what are undirected advertisements? So basically it's the most commonly used type of advertisement. The master device can scan to these advertisement packets, and if they want to connect with the devices, they can connect, or these are the general advertisements, or basically undirected advertisements. So I name them as a general advertisements. The directed advertisements are basically if a master device wants to communicate with the slave device, which is known, and the device already knows about it, and it wants to communicate, or the slave device wants to communicate with the master device, a known master device, and we want the device to communicate as fast as possible, then we can use the directed advertisement. And once the master receives this packet, it will immediately send the connection request to establish the connection. So it's basically used in with the devices which need to provide the fast connection recovery or fast connection response. So we use the directed advertisement for that. The next one is non-connectable advertisement. Non-connectable are basically the devices which advertise the data, but they do not allow the other devices to connect with them. And connectable devices are those which can connect, and in the response of the scans, they can advertise more data. So basically we will mostly use the undirected advertisement, and in some cases we will use the directed advertisement. We also have the extended advertisements, which are basically the advertisement of undirected type, but once they are connected with the device, they will transmit further data, they will provide further data for the advertisement. So we can use that as well with the BLE. There is one more type of advertisement. We call it periodic advertisement. I haven't mentioned that in those here, but the periodic advertisements are basically they serve the same purpose. Once the device starts listening to these periodic advertisement, it will keep on listening more of the data from the advertiser or the advertising device. So we will not see those, so I'm just discussing them here just for the sake of knowledge. Now let's see the structure of the BLE advertisement packet. So BLE here in this case is Bluetooth Low Energy, and this is the basic packet format. And here we can see first we have a preamble, and then we have access address, then we have the PDU, which is the protocol data unit, and then we have CRC. We have the least significant bit from here, and the most significant bit is on this side. So the first byte is basically a preamble, and the preamble is basically a sequence of the bits which is alternating, or basically which is changing, and it depends on the access address. The first bit of the access address will decide what would be the preamble. For example, if the first bit of access address is 1, then the preamble will be 1 0 1 0 1 0 1 0. So if the access address first bit is 1, then the preamble is going to be 1 0 1 0 1 0 1 0. So basically it's a alternating sequence of bits, and these changing bits can help the receiver to configure its automatic gain control according to the preamble wireless signal strength. So the next one is the access address. There are two types of access address. So I forgot to tell you that if it's 0, the starting of the access address is 0, then it's going to be 0 1 0 1 0 1 0 1. Now we are going to see the access address. The access address is basically of two types. The first one is advertising access address, and the second one is data access address. So once the device is advertising, so it's going to have a special access address. This access address has the address as 0x8E89BE9. D6. So this is going to be the access address if the device is advertising some advertisement packets. If it's transmitting some data, then the access address would be of any other random value and not this value. So for the advertisement, this access address is specific, and this will always be this address. And we have some general rules for the access address, that the access address, if it's a type of data access address, then it should not contain all the bytes as zeros or as ones, or it cannot contain 6 zeros in a sequence. Otherwise this would be not the data access address, and the specification says that it should not contain the 6 consecutive zeros or 6 consecutive ones. And it cannot be similar to the broadcast access address, which is this one. This is the broadcast or advertisement access address. And one more condition about this is that this access address should not contain the flip bits like 101010 or 010101 consecutively 24 bits in this sequence. So they should not be present like this in the access address, otherwise it will not be a valid data access address. So we have some specifications for this. If you want to see the specification more, so you can check the Bluetooth official specifications manual. Now let's move to the protocol data unit, which is PDU, and here we can have the advertisement data or the other data. PDU has 2 parts. One is the header, and the header contains 2 bytes, and the payload contains 6 to 37 bytes. It depends on the data. So these bytes are the 2 bytes of the header are opened here, and let's say the first byte is up till this point, and the second byte starts from here to the end here. The first byte will represent some of the stuff here, and the second byte will represent other stuff, and then we have the payload. First, let's see the second byte because it's easier. It has a length part which is 6 bits long, and it basically tells the length of the payload or the data in the advertisement packet. And 2 bits are reserved and they are not used, so we won't see them being used in the advertisement packet. We will see these in the sniffer using the Wireshark. That I have already made a tutorial on the Wireshark and how to install the BLE sniffer. So if you haven't seen my tutorial, just watch it and install that, because after we start coding the advertisement, we will see all of the advertisement packets, and we will debug if we have some data in the advertisement packet and it's not being advertised. So we will see what happens and how to debug that. So BLE sniffer is really important for debugging, and it's really useful. The first byte of the header is this, and the second byte is this. The first byte has the PDU type, then it has a reserved bit. The first 4 bits are basically the PDU type. The 5th bit is a reserved. Then we have a channel selection bit, TX bit, and RX address bit. We have these 8 bits, and they represent some of the stuff. So first, let's see the PDU type. So we have to move to next slide to understand this. So here we have a basic PDU type. So if these 4 bits are 000, it means it is indicating that it's advertising. The direct advertisement indication, or it's non-connectable advertisement. And we have some for master devices, but we will not see them because we are seeing from the slave's perspective now. We will see them from the master's perspective in the future tutorials. If a device has received a connection request, then it's going to respond. Our slave device is going to respond to that. The header basically contains the 4-bit which are PDU. The next bit is reserve. The channel select bit is basically about the algorithm, and it's the device. If the device suppose this channel selection algorithm, then this bit will be 1. Otherwise, this bit will be 0. The channel selection. If you want to see the more about this, you can check. You can check the BLE's official specifications. We will not go into details about this. Then we have TX, and the TX address is basically this bit is for the advertising device, and it represents if the device address is random or public. And if we set it to 1, it's going to be random, and if we set it to 0, it's going to be public. So we will see about this because in the next tutorial we will study about the random and the public addresses, and because these are really important. This is a really important topic. And first of all, we are going to learn about the addresses, how the devices have their addresses in order to communicate with the other devices. The slave devices will have their specific addresses, and there are many types of addresses. We will see what types are there and everything about them. Then we have RX bit, which is for scanning devices or the master devices. And if bit is set to 1, it means that its address is random, and 0 means the address is public. It's basically the concept is similar. Then we have the length. Length is basically the payload, as I have already discussed about this. It's about the payload's length, and the payload is the actual data. So here we can see that we have lots of other stuff along with the payload, which is really important to be sent on the advertisement packet. Otherwise, it's not going to work. So we have so many specifications. If you are new to these, just take it easy and slowly learn these concepts. And once you know the basic concepts, you will understand how everything is working and how the devices are communicating. Now let's move to the payload, and here we have the payload, and it can be from 6 to 37 bytes in case of normal or directed non-directed or directed advertisement, and or general type of advertisement, and it can be of more bytes if it's extended advertisement. So let's see the payload, and in the payload we have first 6 bytes which represent the address of the advertising device. For example, if I am the slave device, and the slave device will have its address, which is 6 bytes or 48 bits long address, and this address can be random or the public address. And as I have already mentioned, here the TX is basically representing the address. The next thing here in this is the first 6 bytes are basically the address of the device, which is advertising, and the next bytes will represent the actual data. So for example, I have advertisement 0, and in advertisement 0 I have the advertisement length. For example, its length is, the length represents this this data, and its advertisement type, and the data itself. So we have 3 things in this, and we can have multiple packet. We can have multiple advertisements in this packet. Well, for example, I'm sending a name of the device, or I'm including some UUID, or so on. So this type will basically show UUID or the name type or anything, and here will be the UUID. For example, for heart rate we have 180D, so this will be the UUID which will be in the data, and its type will be UUID, and the length will represent like this is 16 bits, so the length will tell that this is 16 bits. So the length will tell if it's 16-bit, and this is going to be advertisement 0, then advertisement 1 and 2 and 3 and so on until this number of bytes. We can add many things in the advertisement. So basically we have a limited packet size, so we have to make sure we are transmitting the data which is necessary in the advertisement. If it's not required, you are not bound to transmit every single thing in the advertisement packet. It's all up to you and your application. Let's move to the next. So previously I have discussed that there are two types of access address: the advertising access address, and then we have the data access address. Basically, if the PDU is the advertising access address, then we have this special address as our access address, and if it's in data, then it's going to be a random address. PDU is going to have a random address, and for the advertisement we have this number of bytes, and for the data channel we can have up to 255 bytes of data. Because of the BLE5 we have lots of new features. If you want to communicate with the older devices, then make sure you are using the legacy advertisement and not the extended advertisement. And extended advertisement is good for the new devices which are BLE 5.0 or later devices. Now let's see how we can program our advertisement. Previously we already have seen in the basic code, the base application code, that how we can program the device. So we will look at the advertisement in BLE, and Nordic SDK has all the framework for us. We just need to define and initialize the values of the respective variables. So okay, now we are going to take a look at the steps. I have made these three simple steps for you so that it's easier for the beginners to start configuring their advertisement packets, and then they can use these functions to work with the advertisement. So for the basics, the first step is the advertisement data is configured in the form of parameters. Basically, we have a structure that will hold all these values. We will see that structure in a couple of minutes. First, we need to see what functions are there, and what things we need to know before we can program the advertisement. So we have all the basic knowledge that we needed, and now we can move on. But first we need to see the general steps for programming the advertisement. So the first step is to call this function after we have finished configuring all the parameters that are present in the structure. Once we have configured them, we will call this configuration function, and once it gives us the value nRF success, it means our configuration has been successfully done. So after we have configured everything, we will just start the advertisement, and for that we have the STBLE gap advertisement start, or ADV start. This function will return us the nRF success value. So once if we receive this value, it means that our advertisement has been successfully started. So now our device is advertising. So the slave device is going to wait for the master devices to send the connection request after listening to our advertisement, or after listening to the device's advertisement. And the last step is optional. So basically in this step we have to, if we want to stop our device from advertising, I want my device to not to advertise anymore, then I will just call this function which is STBLE gap advertisement stop. It will also give us this return value nRF success. If we receive this, then it means our advertisement has been successfully stopped. One thing should be noted here, that advertisement can be stopped in two ways. One method is to start the advertisement with the specific time. For example, I want my advertisement to start, and it can keep on for 180 seconds, and after that my device will stop advertising. It will not advertise anymore. And the second way is to use the BLE gap advertisement stop function. This will also stop the advertisement. Now here is a basic advertisement flow diagram. So I have made this so that you can understand how everything is working. The soft device is basically the Nordic's soft device. For nRF5 to 832 we have 132, and the soft device is 132, and if we are using nRF5 to 840, then we have 140 as the soft device. And the app is basically our application program, the base code that we have already written in the previous previous tutorials. If you haven't seen my previous tutorial, just watch them. We will need that base application code, and we will keep on building the more code or more application specific data on the same base code. So it's really necessary, so make sure you watch that tutorial and see all the basics, what's happening and how it's happening and how all the code is working. The time is flowing downstream, so we can see the time is flowing like this. We have some functions that we do, and after these functions we will receive some of the data back from the soft device. Basically our soft device is taking all these functions as the API calls, and then it returns if everything is going smoothly, it will return us the success or not successful error messages. First of all, our application will call this function which is SDBLE gap advertisement set configure, and it will give it to the soft device. It will call it from the application, will call this function, and the soft device will execute it, and then soft device will give it back. So basically this all is in our devices, which are nRF52832 and nRF52840. So up till this point our devices are basically working on this. The soft device is also present and along with our application code. So the code is working like this. So first we call the advertisement configuration, and then once the soft device configures everything according to our configurations, then it will give us the nRF success. We will read this nRF success in the application code. Then after this, the next instruction will be executed. The next instruction here in this case is SDBLE gap advertisement start. So this API function will tell the soft device to start advertising, and if everything goes smoothly, the soft device will give us a nRF success message, and it will start advertising now. Now it's advertising on the air. So these packets of advertisements are in the air, and they contain all the data of our advertisement, and they are going into the air. And here will be our scanning devices. In this case it can be our mobile device, and they can be using the Bluetooth, and they can be using the Bluetooth to communicate, and these can be our master devices. And the master device on this side will receive these advertisements, and it can see all these advertisements from our device. Here you can see our device is advertising over time. It's advertising if nobody or no master device is connecting with it. After if we are calling a function from our application, that the function is SDBLE gap advertisement stop, so it will tell our soft device to stop advertising, and the soft device will not advertise anymore, and it will give us an nRF success. Or there could be another way. If we don't give this function, or instead of this we set a timeout period for our advertisement, like 180 seconds or 60 seconds or whatever time you like according to your application. You can set that, and once that time passes, our device will receive this connection event which is BLE gap advertisement set terminated. So we will receive this event, and this event will tell us that our advertisement has stopped. So by this way our devices can start and stop the advertisement. Now we know the basic way how our device can advertise and stop it, and how it's working. Now we will see the real code, but before that let's see what is present in the advertisement packet. So I have taken a picture of a structure. So this structure explains what type of data can be included in the advertisement packets. So we can see here we have a name type, we have short length, include appearance, we have flags, then we have a TX power level, like the transmission power level, then we have UUIDs. What is a UUID? I will explain this in the later tutorials. We will cover every single thing in this structure, don't worry. And this structure is basically holding all the basic values that we can transmit in our advertisement. We have this solicited and then P slave connection interval. If we want to include our connection intervals in the advertisement packet, what are connection intervals? If you don't know about this, just watch my previous tutorial, and in the future tutorial as well I will cover it. So make sure you watch my previous tutorial to know the basics. And then we have manufacturer specific data or the vendor specific data. Some vendors of the Bluetooth devices, they want to include some special data in their devices advertisement packets. They can do it by adding that data here. We will see a tutorial on this as well. As I have already mentioned that we will work on all of these, so don't worry, we will work on all of these one by one and we will see how everything's working. We have service data array, and then we can also include the services data. These are basically relevant to the security, and we will see that as well. So let's first see what are the important parts of this. The first one is the device name. From this structure, I've taken out all the basic things that we need to understand. So the first one is the device name. Device name has two things in it. One is the name type, and one is short name. Our device has a name. Every Bluetooth device has a name. We will see the tutorial on this as well. We will do the programming on this, on everything that is mentioned here. We will program that. So we will program everything one by one. The device's name is basically, if we want to include the device name, for example, my device name is Sam's BT or Sumer's BT, then it's just going to be a small device name. But what if I have a full name? If I have a device name as Sumer's Embedded Engineering, this is going to be a long name, and it has so many bytes of characters in it, and it's going to take all of the advertisement packet. So here in this case, it's not a good way to transmit just the device name in the advertisement packet. Then we will have less space for other stuff. So for this we have a special way. We have a short name. The device will have this short name, and after connection the device can request for the full name of the device. And then we have the appearance. For the BLE appearance, our devices have a appearance type, and there are some standard appearances which are defined by the SIG, which is special interest group. They have a special list of the appearances. We will see the list of appearances as well, and we will see everything. And appearance is basically a type. The appearance will show what is the type of the device that we are communicating with. So if we set it to true, then we have to include appearance, and for example, heart rate is the appearance. From the Apple devices, we have Apple Bluetooth mouse, so it shows the mouse icon when we connect with the device. So these icons are especially relevant to the appearance, so this can enhance the user experience. We will see that later on. Then we have flags. The flags basically indicate the device support, and for example, if the device supports the legacy BR EDR, if whether our device is just LE or low energy device only. So here in our case, nRF5 2832 and nRF5 2840, and also there is another device which is F52833. These all devices are basically LE only. and they support only the LE or low energy type. These devices are the LE, so we can include that in our flags, so the connecting device knows what type of device is it. And in the flags we can also include if our device is advertising for an unlimited period of time, or it's just advertising for a limited period of time. We will see what flags we need to include for that. We can to show to our connecting devices that what type of our device is. Then we have transmission power level, and for this we can also send the transmission power level. For example, the transmission power level is 4 dBm, and then we have a service data array. So for example, if we want to include some data, for example, our device has a battery and it's sending the battery's charge power level, and we want to send that, so we can include that as well in the advertisement packets, so it can show if our battery is charged or not. The next thing we have here is the slave connection interval. If our master device before even connecting wants to see what are the connection parameters, then it can see the slave's connection interval data, and it can read that as well. In this case, if we include the slave connection interval, and we can also include the services UUID, which are more available. If we can include some part or the partial UUIDs, or we can include the complete UUIDs, it depends, in our advertisement packet. And then we have request services UUID table. If we want to request for services UUID list, then we can include this, and we can also include the vendor specific data or the manufacturer's data. For example, you are creating some special application and you want to include your data, you can use this. And then we have include device address, so basically it includes the device's address. Today we have learned all the basics of advertisement. We have seen what is the structure of advertisement packet. We have seen some of the basics, what are the specifications and all the other stuff. Now let's see in the programming how the advertisement is being programmed, and we will then see the Wireshark, which is previously installed by us. Now we will see how we can see the BLE packets in the Wireshark as well. So first let's see the project. So first of all, open this PC and then go into the C directory. Here we have nRF SDK, and then go into examples in my projects, and we have created base project. We will just open this base project, and we will see how the advertisement is being programmed. So here I'm gonna use PCA 10056 because I'm using nRF5 2840 this time, so I will be opening this one. If you are using nRF5 2832, make sure you open PCA 10040, not 10056. So I open S140, which is the soft device for this device, and then open the SES, which is Seger Embedded Studio. Open EM project file, and here we have everything. So in this code, let's see where is the BLE configuration set as we have seen. Let's see the BLE configuration. I will also put a picture of that as well, the 3 steps that we mentioned in the slides. So the first step is the configuration, and we will just go into advertisement init function, and here we can see there is a structure. We will learn about this. We have seen this structure, but we will learn further about this once we start programming it. But right now we are just seeing the steps. So here we don't see any gap configure function here. But where is the real function? The first step that was I presented there is actually inside this, which is a BLE advertisement init. So if I right click here and click on go to definition, you will see that everything that we configure over there is then configured and set, and you don't need to worry about all of this code. I wanted to show you this function, which in the end makes all the configurations, and this was the step 1. So in order to make everything short and easier, this function will handle everything for us. We just need to initialize the init structure, and we have seen that BLE advertising init structure in the slides as well. So that structure is basically, let's open this, right click here, and if we see, and here is the structure, and in this structure we have this base structure, which is the advertisement data. If we go inside this, and here we can see all of our things that we include into our advertisement packets. So everything can be initialized as accordingly. So if we go back to the main function, and we see that init is a variable of type this BLE advertising init t, and then inside this we have this structure. So basically, if it's saying init.adv data, so it means it's referring to this structure adv data, and then in the end there is a type or stuff like, for example, name type is BLE ADV data full name, so it means the device is going to advertise its full name. It's not going to advertise the short name. We will see these tutorials later on. I'm just explaining the steps in which we do the configurations. So first of all, we just create this stuff here, this structure here, and then we do the clearing of the structure, and then we put some advertisement data. For example, we are putting in flags here, we are including the appearance here. We will see everything later on, and then we will initialize it. So in the end, once we initialize it, it means it's going to configure it. Once the configuration is done, so step 1 is done, the second step is to start the advertisement. So if we go back into the main function, here is our main function. If we go here and look at the advertisement in it, which is the advertisement in advertising in it, which is advertisement initialization, basically we can see the advertising start is done in the end after the initialization. So this one is the second step, and if we go to this function, which is basically here, it's just calling simple function BLE advertising start, and here we are mentioning the advertisement mode, which is fast. By the way, this is just Nordic's way of telling the fast advertisement and slow advertisement, but it's basically a general type of advertisement. Here we are starting the advertisement. Once we start the advertisement, the device will start sending the packets on air. Then there is another device which is going to connect with this, and after the connection, the advertisement will stop, or the advertisement can be stopped by calling advertisement stop function, or we can set a timeout. So there was another condition for timeout. So let's go to the time interval for advertisement. So here we can see that the app advertisement duration is set to 0. So if we set it to 0, it means the advertisement will be unlimited. But if we set it to some other value, then it's going to be a limited time period. We will see that later on. Right now it's not our concern, but we have seen that we can configure it there, and that is basically this one is basically called here in the advertisement in it, and here is the timeout interval. So basically we are setting the timeout interval to 0. It means it will advertise only for unlimited time, but if we set it to some other unit of time, then it will depend on that timeout. So we can configure that. We will see that later on. Right now we know that how we can start and stop and initialize the advertisement. So this is the basics. So let's put this program once more, and then let's see the Wireshark as well. So first I'm just going to connect my device. So this time I'm using nRF5 to 840. So once the device is connected, click on the target and connect, and then go to erase all, and then download it. And it's saying it's out of date because it needs to compile it. So after compilation, it's going to download it into my device. And if I want to see the outputs, I'm using the MOBA X term as well, and you can also use the PuTTY as well. So this time let's open this one and go to sessions, serial, and baud rate is 115200, and 340 is the COM port on which I'm gonna see. And let's reset my device to see the output. So here it's just telling that the advertisement has been started. Now the device is advertising. So how do we see these packets? Make sure you connect the USB dongle that we have programmed. If you haven't seen my previous tutorial, just watch that first, then come to this tutorial. So now I'm gonna plug in my dongle, and then I'm gonna open Wireshark. And once I open the Wireshark, then it's going to read the BLE packets from the dongle as well. And here is our nRF sniffer for Bluetooth LE, and I will double click on this to open this, and now I can see some of the devices being advertising their data. And here it's a little difficult to find out your device. So I will open my phone and then open the nRF Connect app on my phone, and there I can see my device named SamBT, and it has a specific address. So in order to find my device here, I need that specific address. So for that we have filters here, and we can use the filter to filter out our device which is advertising. So for that we have to use BTLE, which is Bluetooth Low Energy dot advertising address. Here we go to the advertising address. From this I can see the advertising address devices, and this address is basically my device's address, which is SamBT. And if I double click on this, and here I can see in the advertisement its name is SamBT, which is Sam's Bluetooth, and the device is advertising here. So we can see that, and we can see some other stuff here as well. For example, the reserve flags, and then we have the channel selection algorithm and other stuff here. Access address is the main one. So our stuff starts from here, and here is the access address. And then if we move further, then we see the header, and here is the length, and then we have the advertising device address. So our device's address is this C190F243B6FB. So basically it's inverted, so it's basically FB B643F290C1. So this is the advertising address, and then we have the entry length, and then we have entry type in the advertisement, and then it's showing the appearance. Here in this case the appearance is unknown because I haven't set the appearance. We will see in the future tutorials how to set this. And then we can see the entry length for the another advertisement stuff, and in another advertisement we have another entry type, and then here it's showing a flag, and the flag is showing the limited discoverable mode, and LE flags. What does this mean? I will tell you. I will explain this in the future tutorials. And then we have another one which has an entry length and entry type, and then we have the device name, which is here. These hexadecimal values basically mean the device's name, and it mean this SamBT as a name. And then we have in the end the CRC for this, which is 3 bytes. So we can see that 2 hexadecimal values represent 1 byte of data. So basically this is all the advertisement packet, and we can see all the stuff in the advertisement packets and everything for doing our debugging and everything. So we need to see these packets and what is being sent. And if we are communicating with some other device, then we can see the data as well, which is being sent over BLE. That's it for this introduction and how to see the packets, advertising packets, and the layers. And here we have filters, and if we click on this, and BTLE means Bluetooth Low Energy, so all the devices who support LE, low energy protocol, they will be shown in this list. So here we have different types of filters. So BTLE dot, and press dot, and you have different types of filters. You can see the channel's name, company ID, we can include that as well, and all the stuff. You can check out all of these filters in the documentation of Wireshark. We will be just seeing all the basic stuff, so that you know what's in the advertisement packets, and what we are sending in our advertisement packet, and everything. That's it for today, and I hope so you have learned a lot in this tutorial. I have been working on it from many days, and recently I have started making these videos, and now I will continue to make more in the future. And please be sure to support me and my channel on Patreon and PayPal, and the links are in the description of this video. And if you have any questions, you can ask me in the comments below. If you are new to my channel, please be sure to subscribe to my channel. If you want to contact me, you can see my email. It's on the channel, and I usually reply on weekends. And thank you very much for watching. See you in the next video.